All right, so as I mentioned yesterday, we are going to introduce normal distribution. Yesterday, remember we talked about mean, median, mode, and then we calculated standard deviation by hand. By the end of this unit, you were going to apply the standard deviation, not necessarily calculate it. You'll be given that. But we're going to look at a normal distribution. Yesterday, I mentioned on page 3 that there are lots of shapes of distributions. So in those notes, if you were gone yesterday, you may not have those. I will give them to you on Friday. But there's 6 different shapes of distributions that we have on there. And while rectangular and J-shaped aren't as common, you don't see those as often. In fact, I've worked mostly with normal, bimodal, positive, and negative skewed. Those come up a lot. We're going to focus just on normal distribution. It would be the most basic and most common one, even in my psychology class. We looked at that when I was in high school. Okay. So, things like human heights, lengths or widths of supposedly identical objects produced by machines are normally distributed. There we go. Their histograms are bell-shaped. Okay, so if you hear bell-shaped curve, think of a bell, and it's got that general shape. You can see one to the right over here that it has a bell shape. Looks very symmetrical. Something can be bell-shaped and it can be a normal distribution as long as it has that general shape. But notice here, it's not always going to be perfect. So if you look over to the left side of it, you have a few of those bars that actually pass the line, whereas on the other side, they go just to the line. They're under it, okay? So it may not be perfectly symmetrical, but it has that general shape, okay? When measurements can be modeled by a distribution that is approximately normal in shape, the mean and standard deviation are often used to summarize this distribution center and spread. So the mean, we're going to try to find that center, will represent the mean, and then the spread, I talked about that yesterday when we defined standard deviation, and just a reminder, standard deviation, the formal definition would be how much the data differs from the mean. So we look at the spread of the data. The farther you are from the mean, the more spread out it is. So the higher the standard deviation, the farther from the mean it is. So if you have small standard deviations, you're going to have a really tall bell curve. If it is a larger standard deviation, it's going to be a much wider and not so tall bell curve. Okay. So first we're going to talk about estimating the mean and standard deviation. So on your notes here, we estimate the mean by finding the balance point of the histogram distribution. So we kind of want to see what's in the middle. So balance point, if I were to take my pen or pencil and try to balance it on my finger, I want the weights on each side of my finger, so the pencil weight on each side of my finger, to be the same. They may not necessarily look the same because if you're using a mechanical pencil, one end has that eraser and the clip if you didn't actually break that clip off. So you want to find that balance point. To estimate the standard deviation, here I am looking right here. The standard deviation, we want to find the distance to the right of the mean and to the left of the mean. That encloses about 2/3 of the value. So we're looking at enclosing 2/3 of the values. Okay. So to estimate the mean and standard deviation for each distribution, I'm going to do the one on the left with you, and then I'm going to pause and have you do the one on the right. So you should pause this video, try it, and check your work. In fact, if you want to pause both of them right now, or just pause the video right now, try at least one of them. Then listen to it and see if you're right. That might save you a little bit of time. Or just to test to see if you get it without much explanation. Okay, so look at this, trying to find the approximate center. So if I'm picturing this bell curve to follow where my pen's going, okay, to me the middle looks like right in between these two lines. So I'm thinking the mean is going to be right here. That's max, like that peak. It's going to be at about 0. Then I want to estimate the standard deviation. So to do this, remember, as it says above, that I want to enclose about 2/3 of the values. 2/3 of the values. So I'm looking at my data, trying to figure out, okay, 2/3, even including the ends. Now this is just an estimate, so it's not the end all. This value is the exact, okay? But to me, I'm thinking if I went 2/3 of the data, that would leave 1/3 left. So you might picture stacking some of these on top of each other. And I'm thinking right in between here. This looks about 2/3 that anything remaining on each end is 1/3 remaining. Okay, so I look from my mean and choose to go either right or to the left. If I go to the right, the distance from 0 to that 0.24 is 0.24. So I estimate the standard deviation, the distance from the mean. So I go from where I said the mean was and go one of the directions. And so I happen to go right to where I had that line. So I look at this data. This looks like 2/3 of the data comparing these other two ends. If I stack them all up, it probably will represent about 1/3. Okay, I recommend pausing this video. Try to do number 2, or the one on the right. I guess it's still number 1. The weights. Okay. Try to find the estimate of the mean, so estimate where that middle is, and then estimate the standard deviation, so where 2/3 of your data is. Remember, for that estimate, you're going from your mean and how far you went from the mean to the right or to the left. Okay. Hopefully you paused it. When I look at this data, I'm looking at a nice bell curve happening kind of like that. And so I'm still thinking that my mean is happening right about here. And then I'm trying to find where 2/3 of the data is. So I look at it as a whole, and I mean, this middle part might look like it's about 1/3. I'm leaning towards maybe right about here. And then right about here would be about 2/3. Now, that's not an exact science. Remember, this is just an estimate that about 2/3 of the data is between those two lines, and the other third is out on those tips on each end. Okay. So again, if I'm going by scale, this is going up by 8. So 404 to 412, that's 8 halfway. So where my cursor is right here, that would be half of 8, which is 4. So the line I marked right here, the solid red one, looks like it's between, about 3/4 of the way between 404 and 412. Okay, so if I want to know the distance from this mean, 404, to where I made this other line where I'm saying about 2/3 of the data is, I'm thinking it's 3/4 of the way to 12. So from here to here is 4. Half of that would be 2, so 4 plus 2. I'm going to say that the standard deviation is about 6. Okay. Let me know if you have questions on estimating this in class tomorrow. But again, with this, remember the mean is going to be that center, and then you're going to find that range of numbers that go from, that has about 2/3 of the data inside of it, to estimate the standard deviation. And you're wanting to know how far away is one of those borderlines from my mean to figure out the standard deviation. So if we move on to the back side, move on to that back. So the data below and the accompanying histogram give the weights to the nearest hundredth of a gram of a sample of 100 new nickels. So there's 100 numbers in this list. You can count it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. Okay, so 10 times 10 is 100. So that's how many total. So if we need to use that later, n equals 100. The mean weight of the sample is 4.9941 grams. Okay, so that is your mean. We want to find the median. So remember, median, that was the same as the middle. So if you think about this, I have 100 numbers listed in order from least to greatest. You go down each column. And so I want to find the numbers in the middle. There's 100 numbers. So since there's an even number, I know that I'm going to have to go halfway. Okay, so, and I know I'm going to have 2 numbers that are in the middle. Hopefully they're the same, right? So I start and I go backwards, and so I go up 1 column down. And you might be like, well, half of 100 is 50, so go find the 50th numbers. So we're going to find the 50th and the 51st. So if I go down this column, 30, 40, I see all the way to 50 that this is one number. If I do the same thing backwards, I go up, 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 and at the end of the 5th one, those 2 numbers are in the middle of my data. Okay, so if I'm backtracking, meeting in the middle, I see that 5 is my median. Okay, then the question, how does it compare to the mean weight? Take a moment, think about that. How does 5 compare to the mean weight, which is listed, that I highlighted in yellow, 4.9941 grams? And I would say that it is very close to the mean. Okay, it is very close to the mean. Okay. Moving forward. Then part B, we want to figure out which one is the following standard deviation. So standard deviation is, remember, we want to look for 2/3 of the data, estimate for 2/3 of the data is in between 1 standard deviation to the left and 1 standard deviation to the right. So I'm looking for how far from the mean. First, I should label where the mean is. So the mean is, up above it said 4.9941. So I find that it is like right here. So let me shorten that a little bit. 4.994. And that is your mean. So if I were to look at this, I might estimate, this is a complete estimation, that 2/3 of the data is somewhere between here and here. Okay, somewhere between those 2 values, which you can hardly see, might be the data. Might be 1 standard deviation to the right and to the left. That's where I eyeball it. Maybe a little bit more to the left. Again, this is a complete estimation. But I look at my values. So I see 0.0253. If I add 0.0253 to that mean, I'm only going to the right, maybe over here. I can tell that that is not 2/3 of my data if I go to the right 0.02 or to the left 0.02. I'd be like in this area right here. So I know it's not that one. 0.05. Now that looks